Hello everyone, I welcome you once again everyone to my digital platform. So let's start our today's discussion on basic logic gates. So we are going to study basic logic gates, but before that you need to understand what is logic gates. So in physics, whenever we are talking about this logic gates, a logic gates has one or more inputs but only one output. So whenever we are talking about this logic gates, the logic indicates a decision making process. A decision making process. That means if some condition will be satisfied, then only there will be output, otherwise there will be no output. So this if you want to explain the operation of the logic gates, we need to use Boolean algebra. So operation of the logic gates can be explained by using Boolean algebra. So this is a new term. What is Boolean algebra? So all of you know every digital electronics is based on this algebra. This algebra only has two digits. And what are those two digits? 0 or 1. It can only read these two digits, 0 or 1. What does this 0 indicates? The 0 indicates off and 1 indicates on. Or you can say this 0 indicates no, 1 indicates yes. Or you can say this 0 indicates it's an open circuit, 1 indicates it's a closed circuit. So whenever we are going to apply this Boolean algebra in the logic gates, we can explain how the current is going to pass in the circuit, or current is going to flow in the circuit. So let us start our today's discussion on the basic logic gates. So whenever we will talk about the basic logic gates, we have three basic logic gates. So basic logic gates are of three types. The first one is OR gate. The second one is AND gate. And the third one is your NOT gate. So today let's start our discussion on AND gate. So this AND gate has two inputs and only one output. So it has two inputs and only one output. The Boolean symbol for this AND gate is dot sign. You can see here I am just encircling it so that it will be remembered. So this is your dot sign. So let us draw the truth table for it and try to understand how it works. So for the truth table, since I have already told you it has two inputs, so let us assume A is an input and B is another input and Y is my output. So what I will write for this Y? This Y is nothing but A Boolean symbol dot B. So this is nothing but A dot B. So now what are the choices I have? So the choices I have 0 0, 0 1, 1 0, 1 1. So whenever the first input is 0, second input is 0, so A dot B gives you 0. 0.1 will give you 0. 1.0 will give you 0. 1.1 will give you 1. So this is the output that we are getting. So now let us try to understand this output in terms of a circuit. So circuit diagram. So we will not go into any complicated circuit, we will just go for the switch circuit. So here we have to take two switches. So let us just name it S1 and S2, which are connected in series. As you can see here, I have taken two switches which are connected in series. Then after that, in series you have to use one resistor, then your LED to check that whether we are getting the output or not. That's why I am using this LED. Then we have to give the supply, and the supply is nothing but a battery. So this one is the positive terminal of the battery. You see the positive terminal is connected with the P side of the, this is your P side and this is your N side of the LED. So now this LED is forward biased. So now you just assume that this switch 1 to be the one input, that is your A, and the switch B to be the second input, that is your B. Try to understand this circuit. Whenever both the inputs, what is 0? What does this 0 indicate? Means the switches are open. So 0, 0, both the switches are open. That means the circuit is open. This is an open circuit. So as the output is drawn across here, across the LED is not going to glow. So the output will be equals to 0. You see, whenever the A point is 0, that means the S1 switch is open and S2 is closed. So this one is closed. If this one is closed, try to understand. But still then the circuit is disconnected. Our circuit is an open circuit. So that's why the LED is not going to glow. In the third case, you see, the first one is closed, the second one is open. The first one is closed, the second one is open. The same condition is there. In the same condition, that means the circuit will be disconnected. So this output is not, we are not going to get any output across this LED. And the fourth condition is when both the switches are closed. Now you see, if both the switches are closed, what is happening? The entire circuit is now, it's a closed circuit. So we are going to get the output. So that's why the output is high, or output is 1. So let's do the demonstration and understand how this AND gate functions. So as you can see here, the two switches must be connected in series. So I have just connected the two switches in series. You can see here, they are connected in series. Then one of the switches is connected to in series with the resistor and the LED. Here also one of the switches I have connected with LED and resistor. Then the other two ends are connected with a battery. So this is a series arrangement where I have just arranged the circuit in series. Now what we have to prove? Whenever both the switches are off, that is 0, 0. You can see here I have just pressed this 0 and 0. The LED is not glowing. This one is the LED which is not glowing. Now you press just second condition. Suppose let us assume that this one is my first input A and this one is my second input B. Then the second one is 0, 1. So the second input has to be 1. So just press the 1. Now you see the LED is not glowing. The LED is still not glowing. So we are getting 0 at the output. That means it's an off condition. So now the third condition is 1, 0. So we have to just press the first 1 to be 1. That is your first input to be 1 and the second input to be 0. You see the LED is not glowing. This one is not glowing. Now we have to do for the last condition, that is a 1, 1. So let's just press the B1 to be 1 and your first one to be also 1. Now you see what is happening. The LED is glowing. So this is the confirmation of this AND gate. Means whenever only both the terminals are high, we are going to get the output to be equals to 1, or the LED is going to glow. If one of the terminals, any one of the terminal is not connected or it is open, then the output is, we are not going to get any output. So this is all about today's discussion. I hope all of you have enjoyed. Those who have not seen the previous experiment on this circuit diagram of OR gate, all of you can watch that. Thank you everyone. Thank you for joining.